All right, so let's begin. So many of you guys have part-time jobs. Not everybody. However, I assume most of you guys probably have some kind of bank account where your $16 an hour. Is that what it is for you guys now? Minimum wage. You guys know when I started at Zehrs back 30-ish years ago, what I made per hour? $6.40 an hour was but on Sundays I got an extra $1.50. But I could also gas up my family van for like $15. So different times. But all of your paychecks and your birthday money, everything goes into your bank accounts where you guys get interest. You guys, what is interest? Somebody, in your own words, what's interest?
It's when you don't know. I don't know.
Yeah, at the end of the month, you get like a cent, For me, like I get like 2 cents, What is that? What is the interest? I'll tell you. So the formal definition of interest is the cost of borrowing money. The cost of borrowing money. So let's jot that down. The cost of borrowing money. So in your bank accounts at the end of the month, you guys, if you have anything in there, might get a teeny tiny little bit, a few cents of interest. That's the second thing we'll talk about here. But you have to pay interest in scenarios where you borrow money. So you pay interest when you borrow money. Now, you guys, some of you guys might have already, I'm not sure if you're allowed to take out a loan, but it's possible if you get a car that, when I got my first car, my mom got the car and then I paid my mom back over time. But like credit cards, car, mortgages are all things where you pay interest because you have to borrow the money. You don't have the money initially. If I wanted to buy a car, I can't walk to the bank and say, hey, bank, would you loan me the money to buy this car? I'll pay you back sometime. And they're not going to say, okay, here you go. Here's whatever cars cost these days, $25,000, $30,000, and just pay me back whenever. No, they charge you for the privilege of them loaning that money to you. And that is interest. But you earn interest when you invest money. That's when you earn interest. You might be asking, Mr. Smith, interest is the cost of borrowing money. Well, when you deposit your money in the bank, you're actually loaning the bank your money. The bank takes your money and pools it with everybody else's money that they deposit in the bank. And they use that money to make investments to basically grow that money. So the bank pays you interest because they're borrowing your money to actually make more with it. So both of these cases, interest is the cost of borrowing money. Today, we want to develop a reliable way to calculate interest when money is we borrow money initially and it kind of sits there and grows over time, or whether we invest money. We want to be able to have a good grasp on that so that we can start to do even more complex financial problems later this week. All right, there's 2 ways interest is calculated in the wild. The first is called a simple interest. So here's a simple situation to keep the numbers really manageable. We're going to borrow $1,000 at an interest rate of 20% every year. We're going to start with simple interest. The idea with simple interest is that the interest you're charged each year, it only depends on how much you borrow. So can you guys jot this down? The interest you are charged each year is based on what you borrow. So it doesn't matter if I pay my loan back in 1 year or 2 years or 3 years or whatever. The amount of interest I'm charged every year is the same. It's always based on the $1,000. So here, You borrow $1,000. It's 20% per year. So the interest that you'd be charged, the cost of borrowing this money, would be just 20% of 1,000. So we've been working with percentages last unit a little bit, warmed up with some percentages. So 20% of 1,000. I mean, you guys can use the mental math. You're intelligent people, but that would just be $200 per year. But with simple interest, it's $200 per year, whether it's the first year or 20th year. It doesn't matter. It's simple interest. Interest is based on what you borrow. So this is a very simple visual for us to do. Let's track our starting balance over the course of a few years and see what that would look like. It might even look like a type of function that we're used to. So starting with year one, we owe $1,000 and the interest is $200 every year. And then we end with $1,200. And then afterwards, year two, we owe $1,200, but the interest is still $200. It doesn't change. And so every year we're just adding on $200. And I'm going to, just for completeness sake, keep just filling in my table, even though the rule is very obvious, just to emphasize it doesn't matter what the starting balance is. We're still just adding $200 in interest every year. I know it's 1,800, 2,000, but I just want to make a point of emphasis there. So that's pretty nice. Even though after year 5, I now owe double as much as what I owed before, but I'm still only getting $200 of interest every year. And then the last one, 2,400. So let's have a look at what, if we plot those ending balances, what that would look like. So after year 1, it's 1,200, and after year 2, it's 1,400. This is looking like a type of function that you guys have been working with for a while. What type of function are we looking at here, everybody? Don't all just, trip over each other at once. Sullivan. It's a linear function. Yes. And we can see, of course, those first differences are just 200 each year. And so, yeah, this is a linear function. You'll notice what I haven't done. I actually haven't made a line between my points here, because this interest is only added on at the end of the year, like you guys in your bank accounts. The interest isn't continuously adding up. You don't see your bank account constantly spinning with the numbers up. No, it's just added on at the end of the year. So that's simple interest, because it's basically, it's simple. There's no other way to put it. Most, not all, but most of your financial dealings out in the wild are going to be with compound interest. Compound interest works a bit differently. With simple interest, the interest you're charged each year is based on what you borrow. It's different with compound interest. With compound interest, the interest you are charged each year now we're looking at this as from a borrowing perspective, but the interest you're charged each year depends on how much you currently owe, which is a bit more fair. Like in the previous example, I owed $1,000, interest was $200 that year. 5 years down the road, I owe twice as much, $2,000, but I'm still only paying $200 of interest. Some would say that's not quite fair. That if you owe double the money, then you should be paying the interest double the interest. And so instead of adding $200 every year, we are recalculating what 20% of what we owe is. And there's a quick way of doing that. I've already spoiled the fun. It's in the table there. So in order to get the 20% interest and add that back on to the starting balance, we're going to multiply by 1.2. repeatedly multiply by 1.2. Why 1.2? Because that's 100% plus 20%. That's 120% year after year. That's why 1.2. So let's see how things were different, are different compared to simple interest. So if we, in year one, we start with $1,000. After that first year, we would owe $1,200, the same as a simple interest. But now, after year two, our interest is going to be calculated not based on what we borrow, but based on this $1,200. So we have to do 1,200 times 1.2. And so we're just going to be repeatedly multiplying by 1.2. And this is the last time we'll do an extended table like this. We'll develop a formula to do this quickly right after this one. I just want to get a visual. I'm willing to bet you guys could already predict what kind of function this is going to be. All right. After year two, we don't owe $1,400 like with simple interest. We owe $40 more, $1,440, because we're getting interest on top of interest. Now, I'm going to, for completeness sake, keep copying over my the starting balance for each year. $1,278. So I'm just repeatedly multiplying by 1.2 in my calculator. Look at that. After year four, I'm already past owing $2,000, whereas with simple interest, I only owed like $1,800 at that point. And we're getting in the habit of rounding to the nearest cent. We're working with money here. 2,488.32. As I said, this is the last time we'll do a repeated multiplication table like this, but I wanted to get just a visual. We're going to graph these ending balances. 985.98. I'm keeping everything stored in my calculator. So if you rounded maybe and we're off by a cent, that might perpetuate down the line, but we should all agree for the most part. 3,583.18 or thereabouts. That's a big difference compared to 2,400 owed with simple interest. Let's graph these ending balances. Should look like a type of function, possibly that we've studied recently. Who can say? So 1,200, just do your best. 1,440 is a little bit over 1,400. 1,728, right around there. 2,073, it's close to 2,100. And then we're almost off the graph. That's almost 2,500. Can I fit the next one on? Almost 3,000. Yeah, I can actually fit this one on. Just at the tippy top of my graph here. That's the formal word for it. So definitely not linear. Growing by more and more and more. Actually growing by the same fixed rates every year. We've got a name for this type of function, right? This type of growth. Exponential growth, yes. That's the end. Compound interest can be represented by an exponential function. All right, so we've compared simple interest versus compound interest. If you guys were wondering why it's called compound interest, it's because after year one, we're now calculating interest on top of interest. So it compounds, right? Compound interest. So we've compared simple versus compound interest. We're now going to just dial in on compound interest. Most The only place I know that uses simple interest, if you guys have seen, Kemper, you with me here? All right, we got 13 days left. We got a down. If you guys, I'm not sure if Acton has any of those short-term loan businesses like Money Mart, stuff like those. Those places actually charge simple interest for short-term loans because they make more money that way. But your bank accounts, investments, most things in real life are going to be compound interest. So now we're going to move into just focusing in on that. So I don't like making a table every time I want to track how much an investment or a loan is growing. So let's motivate a formula for doing this. Now instead of 7 years and repeatedly, we got the 7-year total by multiplying by 1.27 times. So that was a really silly way of doing it in hindsight. Maybe not since we wanted the graph, but if I was just concerned with how much I owed after 7 years, just multiplying by 1.27 times, that's a little slow. It's a little inefficient. We can do that more quickly by, I don't know why I have, this is what we did before. This is the visual of the silly way. We did 1,000 times 1.2 times 1.2. I'm already tired of doing this. I'm just going to put ... We don't want to do repeated multiplication of 1.2. But after our last unit, we've got a much more practical way of modeling this type of scenario. We're taking 1,000 and we're multiplying by 1.27 times. It's just exponential growth. So we could just do 1,000 times 1.2 to the power of 7. And if you guys just try that, you're going to get the same ending balance that we got by repeatedly multiplying by 1.2. All right, can you guys humor me? Make sure we just have the functionality in our calculators. What would we owe in 20 years, in 30 years? Obviously, repeated multiplication of 1.2 doesn't make any sense. Let's use this new, it's not really a shortcut. You guys did this all last unit. We're motivating a formula we can use to calculate compound interest. Okay, so that's pretty big. 38,337.60 is what we would owe in 20 years if we just let this loan grow unchecked and never paid it back. In 30 years, yeah, we're going to keep it 100 or keep it 1,000 for sure. I anticipate this is going to be quite big. So 20% per year unchecked for 30 years, $237,376.31. Now, if this was simple interest and you added in $200 onto your balance for 30 years. So if you did simple interest here, you'd owe $7,000. With compound interest on top of interest, you pay back $237,000. Crazy. The power of compound interest. This motivates a nice, tidy formula, and this is just kind of the starter level formula for today. We're going to add to this so we can do even more complex problems. This is our compound interest formula. It introduces some terminology and some notation we'll use for the remaining 13 days of class. So here A is our future value. It's like how much we will owe or how much we will have at the end of our kind of investment period or loan period. Capital P, we will call our present value. You also might see this called the principal. Principal with an AL on the end, like Principal Skinner. Do you guys know who Principal Skinner is? No. From the principal on The Simpsons. They're still making new episodes of The Simpsons. You guys let me get off track. How dare you? R stands for rate. shockingly enough. Now I'm going to add a little note here. This is as a decimal. We've got to be careful of that. And in this simplified version of this formula, T stands for time. And in this version, it stands for years. Essentially, this is just a glorified exponential growth equation from our last unit. So you guys should be pretty pro at this already. Life is good. Here's a scenario. Let's give this formula a spin. We'll give it a spin a couple times before adding to it. So I like just doing these tables to start off with. So Andrew, yes, Kervin.
Is there a student teacher gone?
Yeah,
Ah, I didn't.
yeah. As a side note, his 3 weeks of observing assisting are done. So I have to do all the marking now. We actually, just as an aside, Mr. H hasn't actually gone to classes yet at Teachers College. The first thing he did was come to a placement, which is kind of weird. But yeah, he's now in the classroom doing boring Teachers College classes. Where was I? Okay, Andrew's borrowing $2,000 for a new gaming laptop. Now we have to suspend belief here for a second. No place is going to loan you money and then just let you pay back everything in 5 years. In reality, you'd have to pay back a bit at a time. We'll get there eventually. We got to start somewhere though. So Andrew starts with, he owes $2,000. The rate here is not 4. It's 4% as a decimal. So if you need to show 4 divided by 100 to say 0.04, then show that division. If you're comfortable just writing 4% as a decimal right away, do that. For 5 years. Let's take our compound interest formula for a spin. It's 2,000. Note the 1 plus r because it has to be exponential growth. If you just put in 0.04, then you'd have exponential decay, which isn't how interest works. Nothing crazy so far, guys. It's just exponential growth from last unit. Easy peasy. Just some number crunching. 2,433, and you guys should be in the habit of rounding to the nearest cent. So for the pleasure of borrowing that money, his bank is going to charge him $433.31. I'm just going to add that $433.31 was interest for this one, even though it wasn't asked for. I'm going to pop that in. It's the compound interest formula. It's not bad so far. Can you guys try the next one? And then we'll ramp things up a little bit. I think we just have one more example there. Yes, okay, so we did a borrowing question. Let's look at the positive side. Asher's getting some birthday money. Asher got $100 on his first birthday. And me being the responsible adult that I am, I'm like, I'm going to save this money for him. What would a 1-year-old spend their money on anyway? Just useless stuff. Actually, my 8 and 10-year-old now spend their money on useless stuff still. Like V-Bucks. Asher collects Pom Pals. So basically, anytime he gets $15, he gets a new Pom Pal. Why'd you guys get me talking about my kids? How dare you? He has like 59 Pom Pals. He's almost at 60 Pom Pals. On that collection, there's like 180 at least.
Yeah, so close.
Yeah, but you know what's depressing is I think of, because like Asher doesn't work. So who really, how much money have I actually spent on Pom Pals in the last few years? Don't worry about it.
It makes him happy.
Yeah.
Makes him happy. All right. You guys go. I'll play catch up. I'm going to do my attendance. You guys do this problem. All right, you guys are not using 2.5, are you? No, you should be using 0.025. please don't make this mistake. If you use 2.5, then Asher's he's gonna be like a millionaire in 18 years. That doesn't make any sense. It's only $100. Don't forget the 1 either. All right, he will have a whopping $155.97. He could buy 10 Palm Pals with that when he's 18. So let me wrap this problem up, and then we'll escalate things. Yes, so Asher, you could buy 6.5 Palm Pals now, or invest your money, and in 18 more years, you could buy maybe 4 extra Palm Pals. How's that for you? I joke. Now, guys, this was kind of a crash course review of grade 9 stuff, comparing simple compound, tying in exponential functions. In real life, though, interest is not calculated just at the end of every year. In most of your bank accounts, it's every month. In some investments or loans, for example, when I first started paying my mortgage, I paid my mortgage every 2 weeks, and interest was recalculated every 2 weeks. So we need to be able to handle all different types of scenarios, and that means we have to have some terminology. Now, after looking at some of your tests, I realize not everybody knows how many weeks there are in a year, so we're going to have to get all on the same page with that.
I had to guess. I guess 54.
You don't have to admit that. It's okay. Now, some of these you guys know, like how many times a year is annually? Once. That's 1 time per year, right? No, 1. And you guys know how many months are in the year, right? 12. Good. You're learning. Now, weeks in a year, it's not exactly 52. It's 52 plus an extra day, but not 48. 48's like if you do 4 weeks per month, then you're missing out on 4 weeks per year. It's kind of a big underestimating. 54, no, not 54. 52 we're going to use, okay? What does quarterly mean? How many times per year do you think quarterly is? It is 4 times a year. What does that mean exactly? You guys maybe make a little prediction. What do you think these mean? How many times per year? I'll wait 30 seconds and I'll show you. Semi means half. Annually means year. Every half year would be 2 times per year, yes. Semi means half. Monthly means month. Every half month would be 24 times per year. Yes, Andrew? No. Every quarter, 4 times per year. It'd be every 3 months, but no, it's 4 times per year. Yeah. Now, I think if you're like me working at Zehrs back as a teenager, most of you guys get paid bi-weekly, kind of every other Friday perhaps. Some people get paid, you guys listen up, some people get paid twice a month, maybe 15th and 31st. So for some people, their investments, what have you, semi-monthly is irrelevant for them, but other people get paid bi-weekly every other week. What do you think bi-weekly means? How many times per year? 26, exactly. It means every other, bi meaning 2, weekly, every 2 weeks, 26 times per year. For daily, you guys know how many days are in a standard year? 365, there we go. All right, so we need to tweak, guys, listen up. We need to tweak our compound interest formula so it can handle any of these scenarios. Because in real life, some of these are used quite frequently. Some are used, like semi-annually is used a little bit with mortgages. Not as often as maybe bi-weekly or monthly or semi-monthly. But we have to be able to handle them all. So how do we do that? We are going to tweak Our compound interest formula. Some things stay the same. Your A is still your future value. That has not changed. Your P is still the present value. That has not changed. But we just can't use a yearly interest rate in years anymore. We have to be a bit more detailed. Little I here doesn't represent the interest rate for the whole year. This is the rate, so we're going to add some new terminology here, per compounding period. So that could be the interest rate per month or per day or per week. It's the interest rate per compounding period. And just like before, it's as a decimal. And N is not the number of years anymore. It's the number of compounding periods. The number of compounding periods. So now when we do our compound interest problems, you guys are going to have to do a quick calculation or two to figure out what's my rate per period and how many periods am I dealing with here. And it all comes down to the terminology we just talked about. You have to pick that up. So let's do an example together to get you guys through a couple more. And I have a short task for you guys today, just in lieu of some practice. I guess with announcements, our time's gone by pretty fast today. All right, here we go. Tom has put $500 in his credit card. His credit card company charges 24% interest. Now, that 24% is for the whole year, but it gets divided up into little monthly bits. How much will you owe in 2 years? So you guys see monthly. You guys have to recognize our language. Monthly is 12 times per year. 12 per year, right? So when you guys are using the formula, the principal, the present value is pretty easy to spot, 500, but you have to do a little bit of calculator work before you use the formula. Our interest rate per compounding period, it's not 0.24. That's for the whole year. You guys have to divide that up into monthly chunks, divide by 12. Why 12? Because it's a monthly problem. Now I usually cook these up so that you get some nice round numbers, at least for our first few. 0.02, that means 2% every month. In 2 years, that means interest is recalculated and compounded, not twice, but 24 times, 2 times 12. Why did we multiply by 12? Because it's a monthly problem. These are the values you use in your compound interest formula. So it's the same mechanics as before, but you guys have to get good at recognizing what type of, is it monthly, is it biweekly, or whatever. It makes a difference. But now it is admittedly just number crunching, whatever that is. If you got signed up in notation, you might have done 1.2 to the power of 24. Yes. Okay. Yes, Gervin.
Do we have a test for this?
We will talk about that, but no unit test for this unit. There's no time. But your final performance tasks are heavily finance based. So I'll just make a brief conclusion here. Thomas would owe $304 or more. Thomas, yeah, that's his name. And I'm just going to make a little note, just using some mental math. $304 in interest. Now, just one more time, I've said this already. In real life, the credit card company would not just let his balance grow for 2 years. You would have to make a minimum payment. We will get there. We're starting simple. All right. Can you guys try the next one independently? I'm going to come around and distribute the task you guys are working on. It's just 6 compound interest questions. And yeah, you guys do this one. I'll take it up. Do the next one. I'll take it up. But give this next one a try. Note the language. This is a weekly problem. So apply the same strategy as before, but weekly in this case. What's the weekly interest rate? how many weeks are going to be
Yes.
everybody? All right, here I come along for the ride. 4,000. Okay, so 5.2%. That's 0.052. It's not 0.52. That's 52%. But we have to chop this up into 52. The little I we will be using in our formula 0.001. You got to make 5.2% a decimal and then chop it up. Little n, 4 years, but we're calculating interest every week. That's 208 times interest will be calculated. It's a teeny tiny bit of interest, but it's applied many, many, many times. All right, I got the rest is number crunching. 4,924.34. She investing or borrowing? She invested. She would have 4,924.34 in those after those 4 years. Okay. If you guys are okay, let's just do the last one together. That way we have maximized your amount of time to just finish that task. And many of you guys can actually get the task done today. It's really quick. We're just getting used to the terminology here. So we're investing 1,000. Our interest rate is 6%. That's 0.06. But we are calculating interest semi-monthly. So you might have to check that table we talked about. Semi-monthly is every half month. It's 24 times per year. You got to chop that up into 24, which should work out nice. 0.0025. If your calculator is giving you scientific notation here because the decimal is small, I can come help you fix that. Just let me know. In 3 years, interest is calculated 24 times per year. That's 72 times. The guys, the calculator work, it's simple. It's just exponential growth. But you guys have to get used to the terminology and being careful with the decimals. Two 5 to the power of 72. So 1,196.95. And if you guys are okay, I'm going to skip the conclusion just so I can get you guys working on the task. Anything you guys want to chat about? If any more is kind of overkill, you guys just need to practice. So let me pause the video.